Okay, so I'm going to show you how to do a one sample population proportion hypothesis test on the Inspire. First, we need a list and spreadsheet. We pretty much always need list and spreadsheet. I've pulled this example off of the internet. So this says newborn babies are more likely to be boys than girls. That's someone's claim. A random sample found 13,173 boys were born among 25,468 newborn children. The sample proportion then was 0.5172. So that's bigger than 0.5. The question is this evidence that in the entire population the birth of boys is more common than the birth of girls? That's what we're trying to prove. The null hypothesis, as always, is the nothing different is happening here. So the null hypothesis in this case would just be that the proportion of boys is 0.5 and the proportion of girls is 0.5. In this case, we're trying to show that they're more likely to be boys, so our alternative hypothesis will be that the proportion of boys is larger than 0.5. So on a calculator, we're going to go to Menu, as always, Statistics, as always. It's not liking me being in the box there. Let me click out of that. Try again. Statistics, and then we want to do tests. Kind of disappeared there. In a video previous to this one, I talked to you about the student's t-test. That happens when your sample is small. This sample is way huge, way huge. So we would want to choose a z-test. But in particular, we want a proportion test. So I'm going to click the HTProp z-test. The proportion with the 0 there, that means null proportion. So that's the 0.5. That's the null hypothesis, was that p equals what? The null is that it equals 0.5, so here's the 0.5. And then we've got the number of successes is the number of boys, so 13,173 out of the total population of 25,468. And our alternative is not that they're not equal, it's that it's actually larger. And I don't really care what this column is, so just click OK. Here's our p-value. If I had not scrolled over that, I would look at that p-value and think, whoa, that's way bigger than 0.05, but look, p is a probability, and in fact this is bigger than 1. If you get something that is bigger than 1, that means it's in scientific notation, so you have to hover over. This is times 10 to the negative 8. That means this is it's 0.00000001888535. Okay, so this is much smaller than 0.05 or 0.03 or 0.01 or any alpha you might ever choose. So that means that we can reject the null because p is low. So we reject the null that they're equal, and in fact this does show that more babies in this population are boys than girls. The z-value, if you wanted it, I talked about the p-value method versus the traditional method. You could look at the 5.5 and say, holy, that's a gigantic z-value, and you'd come to the same conclusion.